of two functions is the same as taking the limit of each function. Okay, so the limit as x approaches a of g of x plus f of x is equal to the limit as x approaches a of g of x plus the limit as x approaches a of f of x. And that also works if you subtract the two functions in the middle. So I'm going to write this as plus or minus. So we're allowed to distribute the limit sign through parentheses the same way that we're used to. Rule number 2, and there will be a total of 6 rules that I'm going to write down here. Rule number 2 says that the limit as x approaches a of a constant times a function, so c times f of x. If I want to work with this, if I have a number times f of x, I can take that number, that constant, and bring it in front of the limit symbol. So the limit as x approaches a of c times f of x is equal to, and bring that c in the front, and multiply it times the limit as x approaches a of f of x. So this is rule number 2. Rule number 3. The limit as x approaches a of f of x times g of x. Now, this is going to be a little bit different than normal distribution that you're used to. Like when we have a plus or minus, it seems reasonable that we can take the limit symbol and put it in front of both the g function and the f function. With multiplication, we're going to do the same thing. Okay? We're going to put the limit symbol, the limit as x approaches a of f of x, times the limit as x approaches a of g of x. Okay? So this is the first sign that the limit symbol is different from just an ordinary variable or letter. Okay? All right, our fourth limit law, our fourth theorem that comes from the precise definition of the limit, says that the limit as x approaches a of f of x divided by g of x is equal to, well, I can put that limit symbol on the top and the bottom, is equal to the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. Now, I want to give you a warning on number 4. Number 4 has an asterisk next to it. Actually, it has several asterisks next to it, because this law is not valid 100% of the time. This law is only valid as long as, once we distribute the limit symbol, as long as we don't get 0 in the denominator. Okay? So if we get a 0 in the denominator after having distributed the limit symbol, all bets are off. Okay? So what the asterisks say is that number 4 is valid as long as the limit as x approaches a of g of x is not equal to 0. All right, and 2 more rules. Once we get these rules written down, these are going to be the things that we can use, the tools that we'll be allowed to use to start talking about evaluating limits algebraically. Rule number 5 says that if I have a constant function, a function that is described by a horizontal line at a height of c, in this case, that no matter what x value I'm approaching, the y value of the function is always constant. Okay, so the limit as x approaches a of any constant is just that constant. All right, and last but not least, number 6. approaches a of x raised to any power, any positive power. Well, x raised to any positive power is some kind of a polynomial like x squared, x to the third, x to the fourth, x to the 256. And all of those functions, well, there's never any holes in those graphs. And so it turns out that the limit, the y value of the function as x approaches a, the y value of our function in fact approaches whatever y value is right at x equal to a. So the limit as x approaches a of x to the n is equal to a raised to the n for n bigger than 0. All right, so this is a list of 6. Now, if you